Okay, wonderful. So my name's Laura Vetter, and I co-founded a company called Evolution a few years ago, but Angela and I used to work together. We worked together for about 3 years or so, and we did a lot of customer work together. So that's kind of how this whole thing started. So what I feel like I uniquely know how to do is how to monitor complex business processes. So we're going to be talking about how to kind of bake that into how you're thinking about moving to the cloud. And I'll spend some time really deep digging into how I see customers monitoring cloud assets now, or even when they're starting their cloud journey, how they're thinking about doing monitoring and what we consider best practice, best in breeds, so that when you guys are thinking about moving to the cloud, you guys can be already thinking about best in breed strategies. So there's my deets. Yep. I went to IU. I work at Evolution. That's my handle if anybody wants to link up with me. So stuff we're going to talk about is that a lot of people, when they think about moving to the cloud, they think about refactoring their software to maybe microservices or things that are more cloud native. They think about DevOps pipelines that will allow them to be really agile and get releases out quickly. And a lot of times they're just like, oh, we'll just use the pre-built monitoring that comes with whatever tool we're doing, AWS or Google Cloud or whatever. And I'm going to really talk a lot about how that works if you use the Google Cloud native things, and what types of things I would at least position that should be first in mind in doing that. And then also what it looks like if you do use something that's more custom built for monitoring, like a Splunk. So I'll kind of contrast the two, but I'll give you what we believe are really good approaches for both. So once the basics are in place, if you're using a tool that supports this, then machine learning based detection mechanisms can be used. And I'll talk a lot about what it takes to do a good job at using machine learning based detection mechanisms, what types of data you really need to get in there, and also what volumes of data are relevant. Yeah, so we'll talk about tracking transfers and changes. So we will bring a little bit of security focus onto this, because a lot of the maturation things that we think about with getting mature in security really are relevant to monitoring for an ops reason. It just really, from my observations, usually when I go into large organizations, the security front is super stable and mature, and the ops front is getting mature. And a lot of times the ops front is doing a transformation like a cloud migration. And so they kind of are going back a little bit of maturity, but trying to hang on to some mature characteristics. So I'll talk a little bit about that. And then we'll talk about just the process of visualization, and then how you can use machine learning to support it. But specifically, you know, what KPIs should you be monitoring, how to handle alerts, and then how to visualize those. And then we use a very standard approach. So I will talk a lot about our approach. Obviously, you don't need to hire us to use our approach. I can tell you our approach. It's really effective in getting in front of operations issues before they become big problems. So the whole goal of this is to become predictive. Like there's a bunch of tools, a bunch of even the native cloud products can really do a decent job at telling you what happened. That's interesting, but then someone else has to tell you like, hey, something happened, and here's about where it is, and here's about when it was. And then you can go pretty easily to find out like what exactly happened. So a lot of this talk is to help you get predictive into what will happen if you don't do anything. So what is likely to happen if you don't do anything? Is it likely that in an hour you're going to be fine, or is it likely that in an hour you're going to be in an incident? We really want to be able to start to tell you, in an hour, you're going to be in an incident. That's the goal. And all of that ties to business needs. So the business wants applications that perform well, applications that have high uptime. They want to reduce risk during a large migration or a large process of undergoing a transformation, because usually there's a really high investment both in people and in tooling and in infrastructure change that the organization is making. So a lot of the reasons why we get involved with large companies is they're investing in a large cloud migration project of some kind, and they're seeing some kind of performance situation happening. And so they want to start to really measure the performance so they can understand, okay, when people are reporting that there's an issue, is there actually an issue? Because if there's not an issue, we'd rather just deal with that as a one-off. But if there is an issue, then we want to look at it more holistically. Even just answering that question can be tricky once you get a really complex environment where you're at first on-prem, then you go hybrid, then you're full cloud, and you've migrated, you know, your organization in phases over to the new systems. A lot of that, just all that change happening, it's hard to pinpoint, you know, what's actually going on. So we'll talk a lot about that. And a lot of the example I'm going to use is around SAP. We actually specialize a lot in SAP systems and SAP migrations. And I realized at the Indie Cloud Conference, there might not be a lot of SAP people here. And I was not an SAP person myself about a year ago. But I will talk a lot about SAP, and I'll just give a brief introduction and then talk a lot about the concerns that the SAP community has. Because if you are supporting cloud and DevOps in your organization and you're not aware of what SAP is, there probably is this very large subset of people on the SAP side of the house who would love to talk to you because they're thinking about the exact same things. If you go to an SAP conference, they're talking about DevOps. They're talking about migrations to the cloud. They call that an S4 migration, usually to AWS or Azure. And so they're thinking and doing the exact same types of things that you are. So a lot of this can be thought about like breaking out of the IT silo, and there's other IT parts that are supporting, you know, really important custom things. So we'll kind of bridge that gap. So what we really focus on, my organization, when we think about monitoring, is key business processes. And I want to talk about why that's different. Traditionally, monitoring starts at the OS level, and then you might get some application logs, and you really try to use that to get predictive, like, okay, we're having a compute issue here, we're seeing threads run out over here, we're having a high spike in errors here. But really it comes down to, what does your business do? Like, is your business a credit card company? So you're in the business of taking payments, like that's what you love to do, and you love to sign people up for new credit cards. And those are the things that run the business. If you're a technology business and maybe you service a bunch of security and app landscape stuff on the Mac operating system, maybe your business is making sure that Macs can connect to you to find out what libraries they need, what new system packages they want, and then also access to a web interface so that admins can go in there and set things up. So if you really like start to think about monitoring as like, okay, what does my business do? And then for the tech that I'm looking at, how does it specifically serve the business? Usually you can boil it down to like 5 to 10 things that you want to start with monitoring as a business process. And that can be things like paying a bill, viewing an outage map if you're a utility, buying a phone if you're a provider like Sprint or Verizon, servicing up a credit report if you're a credit reporting agency. So really just thinking about like, what does the business do? Okay, and you may need to go ask some people in the organization, but really understanding what the technology that you're providing, especially during a cloud migration services, can really help make the monitors focus on what the business cares about. So some of these, once you get to the underlying tech, they get quite complex. And as they get more complex, you get more and more data that you are able to surface. And that is a wonderful thing. And that is an absolutely horrifying thing at exactly the same time. Because if you have so much data, then the question becomes the most important thing. What am I asking the data? What am I going to ask it to tell me? And I think traditionally when we think about monitoring, we think, okay, let's ask it about how our compute layer is doing. Let's ask it how our thread counts are doing. Let's ask it whether or not we have any database locks. Like, we get immediately down to root cause without thinking, okay, maybe I do have some database locks. Does the business care? Does anybody even know? Like, that's something that if you start with the question, what does the business care about? Then if you do see a lot of database locks, you immediately can look at something to say, oh, good, I can resolve this and nobody ever knew it happened. Wonderful. Or, oh my gosh, this is starting to cause an outage. Let me put aside the other work that I was going to do and make sure that gets fixed right away. So the cloud challenge, you know, it's not like you can just take what you have and move it. There is a lot of change that goes into a cloud migration. because a lot of times you are refactoring and reformatting and changing how the application fundamentally works by maybe moving to microservices, or even moving to like a shared service model, or moving to where you're offloading some of your workload to maybe even a system that is cloud native that you don't own, that services your application in some way. So because of that, there's so much change that happens. We do tend to tackle cloud migrations in phases. So really understanding, if you get the monitoring right, then you can really adapt to a high rate of change. But if you don't get the monitoring right, then the high rate of change is really your weakest link in the chain. So really, if you do this right, then you're not spending your time trying to figure out, okay, we just did phase 2 of a 5-phase process, and we're getting reports from customers that there are performance problems. And so now the team that normally would move on to phase 3 is going back and looking at phase 2 hard again to say, why did something happen here that's bad? And when they do that, it really slows the project down. It increases the risk for the next phase tremendously. So all of that is bad for the business. But if you really are intentional at the front end, it doesn't take extra time to do it right. And then when you do it right, you really free up the risk for the later phases by making sure that the first phases were successful out of the gate. And if they weren't, you can quickly get to the bottom of what happened. So again, the goal time being business aware data. When you go to the cloud, now a lot of times you're bringing a whole lot of extra tech and sometimes newer tech into the equation. So when you are on-prem, you have storage, servers, networking, virtualization. When you move onto the cloud, you have all of those things, but a lot of times those are obfuscated by your cloud platform. So you're really interfacing with the cloud platform, and then you may be even moving on to higher level tech like containers so that you can get a lot of the benefits cost-wise from the cloud right out of the gate. So at the end of the day, this translates to data, and that can be events, traces, metrics, all the types of things that you want to get together and correlate and really ask the questions, okay, what's happening and is it relevant to the business? So this is the game plan that we bring to the table when we do this for people. And absolutely, you guys can do this all on your own. It's no secret. So first we get access to the data. We surface the data, we get it into a tool like Splunk, we get it into someplace where it can be searched, we get it into someplace where it can be correlated. Then in the implementation strategy, we define what's critical. So we'll sit down with the application team and the business and we'll say, okay, what does your company do? Well, maybe your credit card company. Well, what do you care about? Well, we really care that people can pay their bill, because if they can't pay their bill, then it does make it fuzzy, like, can we collect interest? Like all those types of questions start coming to the forefront, and we don't want any of those questions. We want people to pay their bill successful, and then they get charged interest on what they still owe. It's perfect. So then we'll say, okay, how can people pay a bill? And then they'll say, well, right now you're talking to the web interface, and they can pay it through the web, which is why we're talking to you about it. But they also could pay it through their phone. They can mail us a check, or if everything goes haywire, they can call into the call center and pay their bill over the phone. So we actually will go to the other parts of the business that they told us, and we'll find out, okay, mobile team, how do they pay a bill there? Okay, call center, how do they pay a bill there? And we really will start to map together the underlying tech that goes into paying a bill, and then surface it all the way up to the top to really answer the question, can people pay their bill? That's the question that we're trying to answer. And then we'll do that for other things that are critical. Like if you sell things, you want to know that people can search for the things that they want to buy, put it into a shopping cart, and ultimately do a checkout. And we will watch that as flow all the way through the chain of the sequence of events that happens to make sure they could do the things at the front end like searching, and they could do the things at the back end like checking out. And obviously there's lots of tech and events and things underlying that goes into that, and we can talk about that later. But the way that Splunk does this, and this is a very, very mature way to do it, and even if you're not using Splunk and are using some kind of other system, whether it be the cloud native systems that are provided, I want you to really start thinking about a common information model. Like a common information model is, I want to think of all of my operating system data with the same naming convention, so that no matter if it's coming from Amazon or if it's coming from my on-prem architecture, a system is a system, it has a name, it has users, and those users do actions and they have a result. And if you look at Splunk's common information model, which is Googleable, you will find that they have all of these different, they're really data models. And so the data that comes into Splunk that you would want to search that is holistic across different platforms or different business reasons, they fit into this common information model. And so you would even want to think about it on the level of an API. An API has a load, it has an average response time, and it has an error count. And those are the relevant things that we found that if you get in front of how that is performing, you can understand how an API is performing. Now, generally, an API is part of a larger business process. So if you fit the performance of all those business processes together, or all those APIs together, you can look at the whole business process from searching for a part to getting through a checkout. And that's really where a common information model like the one that Splunk has really shines, in being able to help you organize the data that's coming in and understand what's relevant. So there's really alerts and tuning that you can have. Splunk has apps that they provide that give you a lot of the out-of-the-box alerts and tuning. We, as a group, have out-of-the-box alerts and tuning that we espouse. In general, when you guys set up your alerts and tuning for your organization, for all of your cloud apps, it is unbelievably powerful if you set that structure up once and then apply it to all of the applications and share it as like a global item that any app that is going through the cloud transformation or isn't going through the cloud transformation, they monitor on the same thing. So they say, what's a key business process? What is its success rate? If you look at the underlying APIs that make up that business process, what is their success rate? And then you eventually get down into, how is the performance of the compute layer doing as a leading indicator that if I don't get in front of it, eventually one of these business processes are going to have problems. The other thing to think about is a standard alerting strategy. I feel like so many times I see developers not thinking about the fact that if they don't do this well, whenever it goes to ops, they will need a translator all the time, which is a big problem. So if you have a standard alerting strategy that say that first the alert gets routed to the dev team, and they basically have a time frame in which they can fix that issue. If it is customer impacting, then they have a short time frame, like 5 minutes. If it's not customer impacting, but could be in the future, then they have a longer window, like maybe 8 hours. And then if it continues, eventually an incident is automatically stood up and an incident response can be undertaken. And that all happens from the platform that's doing the monitoring. So it is routing the alert to the right personnel, depending on how important is it. If it's business process impacting on one of the ones that we've determined is important, very important, then it's automatically going to cut an incident and people are automatically going to get engaged in that. And then we have standard dashboards. So the process of visualizing a business process, there should be standards that are built for the organization. Visualizing the performance of the technology in the way that's business relevant is unbelievably important. And if you do a standard first, and we think the standard should be 1 to 4 dashboards, that's all you're doing the design work on. And then no matter what business process you're looking at or what application you're looking at, you basically can copy that in, because all of the standards where we use the common information model before, all of that is going to help flow up so that those standards can basically be popped in. All of this is around reducing risk, increasing effectiveness of what you're doing, and making it where it's rinse and repeat. But you really want this alerting strategy to be something that comes with your DevOps pipeline. Like it's all baked into it, so that when you send something through the DevOps pipeline in the right way, you really get alerted when your business has changed. And that way you can get to doing daily releases or weekly releases or whatever your business wants to do. Then we do integration with other monitoring tools. So If incident is run out of ServiceNow, then we send auto cut a ticket to ServiceNow. If an incident is run, if part of the notification system is PagerDuty, because PagerDuty has this understanding of a team and who's on call, same kind of thing with X Matters, we'll do an integration with those so that maybe first we'll email the devs that are on call and say, hey, there's something going on that if you don't do anything, you're gonna get into an incident. And then they enter something that we consider as an incident. Then we page them. And that requires the acknowledgement. And that's why we page them, because we say now it's active. Like the dev team that's on call, they have to say, yes, I'm looking at it. I've got it. Then after 10 minutes, we auto cut an incident, because that actually wakes up another team that actually a lot of times is onshore, offshore. They have a follow the sun model. They're on the hook to always be the wolf at the door. And so we get them involved so they can make sure it's being looked into if they need to start to correlate other teams. And this really is where you get into a proactive. So now your customers aren't telling you that you have an issue with your application. You're telling yourself, your tools that you've spent a lot of money and time setting up the right way, they're telling you that something's happening. So this is the game plan that we go after. Accurate and efficient data sourcing. So we really want to have standards that go into this common model about what it is specifically that we're going to monitor. We put that into Splunk's common information model. When a monitor goes out, so a monitor is something that somebody's going to take action on. It's an email, it is a page, it is auto cutting an incident. Those cannot be noisy. Like they cannot be noisy. If they get noisy, people will turn off the integration. And you guys know, because you've seen it too. It happens every time. Alerts can be noisy, or an alert is something that no one gets notified of. Like it can be like, hey, you had one long running transaction. Congratulations. Took a while. That happened. Didn't seem to happen again. So the monitors didn't pick it up, but we knew that it happened. The reason that we want alerts is because for machine learning, it really matters that you capture a record that something unexpected and unwanted happened, because that really helps the machine learning engine understand what's happening. Then you want reports that are insightful. So you want dashboards that give context to what it meant for the business that the CPU spiked. You want reports that are insightful to know this JVM heap went way up, but it was the middle of the night and nobody was on the system, and so nobody cared, and so it didn't matter. You want appropriate personnel to know how to handle the monitors, and that's institutionalized. So the monitors are the things that cause people to take action, and whoever is tasked with taking that action should know how to deal with the monitor that they get, what it means to start to do an investigation, how you click through the various tool sets that you have to find out what's going on, how you can quickly get business context to know, is this just a one-time thing, or is this a long-time thing, and how many users are impacted? And if you do all this right, it frees up the organization to pursue other use cases. So I'm going to talk a little bit about what it means to be ready for this. So AWS, you can have a phase migration strategy. This link is for, really, it's an older article, but we still think it's amazing. It's basically migrating some existing applications to the AWS cloud. So you want to move and optimize one service at a time. You want to baseline the service's performance beforehand. So that's why you want to get the monitoring strategy in place. You can do a light level on the old system that you're doing the migration on, and then do the full Monty with deep root cause things in the new system. It's ideal for a large system to reduce the risk, and it helps to keep the rest of the app stable and secure. And when you're not, that's not the one you're migrating, but maybe there's some integrations and some hooks that might be impacted. So identify the right candidate for the migration, something that it's underutilized, or you have an immediate need to scale. You really feel like you can get the cost benefit of why you would do the migration. Once you identify what you're going to move, then it's time to think about, okay, where do we want to be at on the maturity curve now and later from a monitoring standpoint? So we think if you think about ops and security in the same way, like I said, a lot of times the security system is really mature in an organization, especially a larger organization that's a Fortune 100 or even a Fortune 500 organization. IT ops can be more immature, but even if it is mature, when you undergo a migration like this, you really kind of have to think of yourself more in an immature state again, and then bring yourself back up to the maturity. So I'm going to be talking through the various levels of what it means to be level 1, level 2, level 3, level 4. And there's some security stuff in there, but most of this is totally IT ops related. So level 1, you're leveraging logs and metrics to investigate. You're really just reactive. Like if you know that there's a problem and you know about where it is, you can find out what happened. Like that's the goal with level 1 is if something happens, do I have enough information, data at my disposal to tell what the heck happened? Sometimes the answer is no. Sometimes people kind of make up the answer. Like they'll say something like, you know what, a database change happened last weekend. I think that was it. What do you guys think? Does that sound good? Yeah, everyone agrees. And they don't look into it any further. And then sometimes we'll get involved and they'll say, and we think it's the database change from last weekend, but it's still happening and we can't figure out why. So that's usually a good indication that the initial hunch, which can be good, like it takes in a ton of context, it takes in a ton of like correlation of, you know, recently this change happened. That's usually a very good place to start. But if it's still happening, a lot of times it is a different root cause, and what you need then is enough information at your disposal to find out what. So proactive monitoring is where you take the way the application works and say, okay, I want to know some leading indicators like compute problems or other root cause problems we've had in the past, like database locks or a database, maybe an SSL issue or a TLS issue, or we had some certificates that failed, and you put in monitors for that. And that can be good and bad. First of all, you can get proactive. That is a good way to get proactive. That is also a great way to have alert sprawl, where you have alerts on a whole bunch of root cause stuff. And now you got to keep all that tuned and non-chatty. And that can be tricky to do, especially against a large landscape. So that's why we can start there, but we need to know that that's not a stopping point and it's not a direction that you go long-term. The direction that you head long-term is to have like situational awareness. So situational awareness is maybe I'm having this root cause thing that's starting, but what's happening here at my API layer? Does anybody care? Like, are any of my customer facing APIs even impacted by any of this? Because if they're not, then the time sensitivity of the underlying issue is not that big of a deal. And eventually what we want you to do is turn off the monitors for the root cause stuff. Leave the alerts in there because they're important for machine learning. But then the things that people get out of bed for, the things that people will do in the middle of the night are related to things that are business relevant. And then real-time business aware is really getting predictive, really having the full context around it, not just am I in an incident, but how many of my users are impacted, which lines of business are impacted, which key processes are being impacted by this outage. And that is ultimately where you want to be. So we'll talk a little bit about level 1. So how do you know you're in level 1? Well, if you're in level 1, you've at least done some rudimentary work to have some monitors in place so you can Google your data. You can look at your cloud, maybe your cloud native tools to say what's happening on the compute level. If possible, if it has something like Stackdriver, maybe you can start to say, okay, how are my key APIs performing? I want to look at the APIs. I want to look at the log data that is derived. If you have something like Splunk, you're starting to put things together so you can at least do like a time-based correlation. Like I know when, I know about where, and I'm going to just get in there with the tool and do an investigation into what happened. A lot of times you're indexing just basic operational data into your big data platform. So what do you talk about? Getting more application data in, getting more business relevant data in, getting your APIs and your timings in there so you can start pull things together. You talk about getting better visibility. So when something happens, you want more context around it. You want the tool to start to tell you when something happens. You want to start to build a consistent and repeatable detection mechanism so that you'll know that something happened. How we measure ourselves, how we measure whether we're doing a good job is whether or not we can reduce MTTI and MTTR. If we can do that, then we believe that we are servicing the business. The business cares that their customers have a good experience. They care that they are efficient, that when internal users are using their assets, that they're very efficient in doing that. They want to eliminate the noise. They don't want to spend so much time doing an investigation to be like, I got a phone call. Is this even a big deal? Like, they want that question to take about 10 seconds where you're just looking at something and being like, nope, it's just you. Okay, now we know that. Now we can move on with our lives. So a lot of this is around, getting yourself on a path so you can get there. So if you go to proactive monitoring alerting, how do you know that you are in level 2? Well, you do start to have some searches that go across your correlated data and they run automatically. And those can generate alerts, and those can generate things that go behind dashboards. So you'll have operational dashboards that start to become the beginning basis of a playbook. So the playbook is, we got a call in, we got an event in from a system. What are we going to do with that? How are we going to start to do root cause on that? How are we going to start to figure out context of what's going on? And you may even have some success stories that let you quickly detect issues before they become business impacting. So you can say like, hey, we had this alert, it fired, it went to the devs and they were able to get in front of it. And you know what, on the next code release, they baked in a more permanent fix for that because they were able to fully find out like exactly what happened. Those are the types of stories that people really start to get behind, like, now we're on the right path. At least now we're doing something that's, seems like it's starting to get in front of issues instead of being behind them. So what do you talk about? That's where I said before, you start asking, what does the business care about? What are the business needs here? What types of things does the business want to see? You start to discuss having a network operations center. So you would start having enough alerts coming out of the tooling that you do have that it would make sense that you had a central location where all of those are filtered so that they can see how it's correlated across the entire business and not just your specific app that you're tasked with or your set of apps. And then you'd want to start talking about how you're handling proactive alerting. Like, do you have a playbook for this? Do you have standard training that your organization runs through? Do you have standard detection mechanisms? Have you guys found things that happen in one application that it would be great if you just applied this across the application set because it applies to everybody? So level 3 is becoming situationally aware. So situational awareness is you're using a big data correlation tool. You're correlating data from different sources. So you're bringing data in from all types of systems, from all the way up the stack, from compute, storage, networking, virtualization, all the way up to containers, all the way up to APIs. You're able to say, okay, I have this business focus and I have all the data that underlies them. You're often exposing issues proactively. So that just doesn't become like, hey, this really cool thing happened. It was like, oh, that sounds like a Tuesday. You're driving standards for operations. So that way, as personnel change in and out, like, they're totally fine. They're able to deal with even personnel changes because all of that stuff is institutionalized in the way that monitoring happens. You're active in the detection community. So your security teams have very similar mandates. They're searching logs, they're trying to find threats, they're trying to find unexpected things, they're trying to see if it's business relevant. And all of those have the same type of ties. So especially with Splunk, because your log data for operations is typically the same log data that security is using, if you can start to talk to other people, even in your own organization, about what's happening. What you want to talk about is even more advanced big data detection mechanisms, like starting to leverage machine learning. You want to talk about being vertical. If you're doing security, you'd want to talk about vertical, specific, and higher quality threat intelligence feeds. And then you want to start looking at machine learning based detection mechanisms across ops and security. So how to use machine learning. Splunk has a great machine learning toolkit. A lot of other tools have machine learning built in. So I think, like, depending on what you want to do, there's many things at your disposal that you can do. The machine learning toolkit for Splunk comes with your Splunk purchase. So if you're sending logs to Splunk, you already have access to that. And I've used that toolkit quite a bit. And the things that I know about it is it takes a really large amount of data, which luckily for all of us, applications and compute and all of the things I listed, it spews a tremendous amount of data. So usually that boxes checked, but it needs some context. Like it needs the alerts in there, and not just alerts from Splunk, but probably alerts from other tooling for monitoring that you have in your environment. Like if you have a networking specific monitor, or if you have something that is cloud native, you could send those alerts into the machine learning pipeline for context. Because what it's really trying to say is, what we've seen in the past is when this situation happens with the underlying data, and then these alerts start firing, we're starting to see that there is a direct correlation that you'll be in an outage here in an hour. And that's the type of stuff that a lot of the machine learning in Splunk lets you do, is to say, okay, when this situation happens, the next correlation it can make is that you're going to get into an incident. So by having not just the raw data that it does, but also some context into alerts that fired and when you actually got into an incident, that's what it needs to get smart on that. And then the fourth maturity model is to be business aware. So business aware is where you do have the full context of which business processes were impacted, which customers, which set of customers, like which stores, if you're store-based, which ones that maybe are tied to an agent or a dealer, which ones maybe I need to call them to say like, hey, customer, you're a large customer of ours and you are having some issues. And we want to tell you that, because I'll tell you what, customers like having that call made to them a lot more than making the call, especially if they're a big customer that does drive a lot of revenue to your organization. You're really tying business relevant processes across applications. So you're tying the whole thing together. So you can see, okay, if I look at this thing as a complete pipeline, is the pipeline running well? And how much is the pipeline processing? And if there's any risk factors for the pipeline, am I aware of those? And you would really start looking then at, you know, for machine learning, I want to start turning it on. Do I have all the things that I need, like the raw data, the alerts, and then also information about when I got into an incident. You'd want all of that information for the machine learning system to be the best possible. So this is a type of dashboard that we do, but we also use this to show how you need to have not just the tech, because each of these bubbles is actually the performance of an application. And some of it, like Right Angle is a big application and it has multiple processes, multiple APIs that are involved. But it's really to show how the whole thing ties together, because when we go in and talk to organizations about these large processes, so this is really about the movement of crude oil. So crude oil is dropped off at a terminal. When that happens, an electronic record is created and sent up to EDS. It then goes through an uploader process. Oops. It gets to Kitty Hawk, and then when it's in Kitty Hawk, it gets reformatted to go into Right Angle. In Right Angle, it's enqueued, it's batched for processing, it goes into an auto matcher. At that point, a price is established. And that is a really time-sensitive thing. So when they drop off the crude at the terminal to when a price gets established, that needs to happen quickly, because that's part of the agreement that, you know, the oil will be priced at the time it's delivered based on a 5-day rolling index, and this is the specific index that we're going to use. So because of that, they need to know that the reporting data, that the pricing data that they're using is recent. Like that's also kind of the tacit agreement that they have with this. Then they also need to know that an invoice gets printed right away, and that those go up into SAP and become part of the permanent record for the organization. So we have several business relevant things, like how many of those movements were initiated? How many gallons did that translate to? Which states had the most deliveries? And then you have some risk factors, like some business risk factors if the pricing data is old. A risk factor to this whole flow stopping is if these database locks happen and aren't cleared. And all of this data was gathered by questioning people that are involved really in the Right Angle piece. They knew their upstream and their downstream things. And then we talked specifically to the SAP team to find out, okay, where do you guys fit into this puzzle? But by doing that, you really can start to measure things as a complete process, and also put the hooks under each step to say, is this step changing? So monitoring with the cloud view, the concept of monitoring with the cloud view is that, you know, it doesn't matter if the data came from AWS or in your on-prem environment. So you can set up the right visualizations and the right measurements, the ones that are business aware, before you actually make the migration to the cloud. And in doing that, you really can understand, was I performing the same way before, at least in the way that my users observe me, as I was after the migration happened? And because the data all looks the same to Splunk, because it's going to that common information model, you really can tell, like, because I made this part move to the cloud, so now my whole latency footprint and stuff is different. Are my users seeing me the same way? Because if they are, then I won, and I can keep moving and I can keep going to the next phase. So the other thing is just knowing where you are in the business landscape. Like if you look at your operational alerts, security alerts, you can look at the programs that were run, you can really see it all together. So you can say, okay, how is my business performing? Do I have any critical system events that I want to investigate, and are those increasing over time? How are my dialogues running? The jobs that are being run in the back end, how are they doing? So we have critical system events here that really tells the stories of the business, but we also have a lot of context around usage so that people can do correlations and say, okay, dude, I have a lot of T codes running at the time, you know, that alert came through, because that would be very relevant. And then knowing for security, knowing who is accessing what. So this talk, we really didn't talk a lot about security, but it's really the same type of thing. Is you really want to know what's happening in your environment, and is it impacting your business? Are people doing things that are unexpected? Are people doing things that are causing a lot of failures? Because if they are, that could be because of a security issue, or it could be because of a performance issue. And then a system health view. So obviously you have the high level business health view. That's what a lot of your monitors are set on. But then the system health view lets you really get to, okay, no matter what the ecosystem is. So it really matters that you have the same view, whether you're on-prem or in the cloud, because people can learn this view. People can understand what this view means. And if you have a bunch of different views, depending on where you are, it becomes really hard for users of that data to navigate what they're seeing. So what are some takeaways that you guys should take with you? So you want performance ground truth during a migration. So because of that, you have to set up at least light monitoring on your previous infrastructure, the one that you're moving off of. And the higher up in the stack that you can get to where you're getting to business process APIs, that's where you want to start your performance monitoring. You want it to be infrastructure agnostic. You want it to go in the same common information model, no matter where it came from, no matter if it is on-prem, hybrid cloud, no matter if it's even some data because you called out to another system that is either another application that doesn't have monitoring, or another application that maybe your environment doesn't even own, like a Salesforce. You want to lean into the key business need during the migration. So that's where I say you go to the business and say, how does this application make money for the company? How does the company make money? And in doing that, you can understand, okay, we need to make sure that this process has the best uptime possible. And in doing that, obviously we care about all the other compute things and all the things that go into that, but we really care that we're watching this. You want it to be business aware. How many users are impacted? How much revenue is impacted? Having metrics like search to buy conversions, API quality. So is the quality degrading even though technically we're still returning in time? And success rate. So maybe you get to a point where you're not returning in time anymore, you're returning errors. So that's stuff that would say, it would be KPIs that you start to measure, but they're business relevant. And then start to merge IT ops and SecOps approaches, like using machine learning, what's working for them, what types of things are they looking at, how are they leveraging a common information model? All of that can really inform merging this approach with what's happening in other parts of the organization that a lot of times are using the same tooling for a different purpose. So that is it. That's the presentation.